Okay, so video number 3. In this video, I want to go over numbers and data and information and how they relate to each other. They're very similar, is the hint. My cat's on patrol in here right now, so hopefully she doesn't disturb us. I'm also going to touch on a couple of computer science-y topics that really just vocabulary for computer vocabulary for ideas that you're already probably familiar and comfortable with, like lists and arrows. If anything in here seems kind of vague, don't worry about it too much. Just, I want you to get exposed to it, and you can always come back and watch the video. Watch the video again. So let's dive in. Blender doesn't necessarily think about numbers the way we do, in terms of a lot of people just think of numbers as numbers. Blender has different types of numbers, and that's less weird than it might seem at first. The two main types of numbers you got to be familiar with are integers and floats. So integers are basically the whole numbers. They can be positive and negative, and Blender uses these to count things that are the term is discrete, but basically there's no continuous or fractional part to whatever it is that you're counting. For example, the keys on your keyboard, you probably don't have half keys or 1/3 keys on your keyboard. You just have a whole number of keys. And then floats, these are used whenever you need a fraction or a decimal point. Typically fractions will just be displayed as decimal points. These are when you or Blender needs to think about continuous values. So something like if you are walking towards something and keeping track of your position in space, or the distance between you and whatever you're walking towards, you're not jumping from spot to spot instantaneously. You move through a continuous value of positions. They're called floats because the decimal point can float along the number and take any place from the right to the left of the number as you need more or less precision. So next is lists, types of lists. I just want to mention arrays. Blender's programmed in C and C++. Probably not going to be relevant to you, at least for a while. In C, the lists are often arrays, and that means that they are not adjustable length. If you see arrays in Python, those are adjustable length. Don't worry about this too much. I just want you to be familiar with the idea that some lists are not adjustable in terms of length. You will probably not run into that for a long time. The next thing I want you to be familiar with is the concept of a vector as a list. And so this is more like a list that you're familiar with, like a shopping list, where you can add things to the end, take things off the end, insert things into it. Computers think of adjustable length lists as vectors, which are a type in C++. We'll touch on types in a minute. But I also want you to be familiar with vectors in the context of math and physics. And so these are basically just arrows, and not lists, arrows. In math and physics, vectors indicate magnitude and direction. Again, you don't need to totally grasp this right now. I just want you to be familiar that the term vector gets used in both ways, in a context for computers keeping track of a list, and in terms of math and physics keeping track of magnitude and direction. Both come up in Blender, so as long as you know that it gets used two ways, you hopefully won't run into the confusion I did when I first started interacting with vectors. Okay, so back to numbers. Let's just say we got a jumble of numbers. They aren't attached to anything. They don't mean anything. They're just totally arbitrary indications of quantity. So they can be arranged or organized or structured, and I'm using these terms interchangeably. And when you do that to them, they become data. So these arbitrary numbers now are a list, right? And so this list still doesn't mean anything. It's just like a nicer way to deal with these numbers. And you can see some show up more than once, but the threes are all the same number. They're all the number 3. So yeah, this is just a list of numbers the way you might think of a list. So when we interpret that, maybe with context, then it becomes information. So it's probably really obvious to you what this number is now. It's a phone number. It has meaning. We know what we can do with it. And the context is the formatting. Most people, I would assume, are familiar with the lead number, area code, parentheses, and then dashes, 3 numbers, 4 numbers, formatting. So the formatting in this case is the context in this case is the formatting. There's a different type of context that we're going to get into right now, and the hint is the word structure. And from the word structure, we get the beginning of we take the beginning of the word for something called a struct. And this is how Blender keeps track of context, which is data containers. Structs are data containers. Think about taking different pieces of different files, pieces of paper with maybe tax information and maybe birth certificates and stuff, and you might file them together into a folder and you label that folder. That's basically the concept of a struct. In computers, structs are really small in terms of computer memory, and it's just a way, if you've got, let's say we've got that list of numbers with no meaning yet. We don't have the formatting that we're used to. We would stick that perhaps into a struct, and the struct would contain a label, phone number, and also contain that list. And because it contains these two things, now Blender can look at it and go, oh, that's a phone number. I know what to do with this arbitrary list of numbers. I will interpret it as a phone number. And also, we can also interpret it as a phone number because we have that, it's together in that way in a struct. Typically, the structs are sort of on the back end in the data API, which you mostly won't look at, but we're going to look at it in this series just to get an idea of how Blender is interpreting things to help us keep track of what's going on in Blender. Another example, you might have this list of letters. And you don't necessarily know how to, or Blender doesn't necessarily know how to interpret these, but if it's in a struct with the label name, now it's got context, and it knows that these letters are a name. And further, you could take both of these structs, put them in a struct with the label business card, and now you've got even more context, and you know that the name Brent is associated with a phone number. I'm not going to read it. And you know that this phone number is Brent's phone number. So you can have a struct of structs, and you can keep putting data containers inside of data containers. The way you might take a bunch of folders and put them into a larger folder, or like a filing cabinet, and then you could have a whole room full of filing cabinets. You can go many, many levels deep, and you don't need to keep track of all the levels as long as you have an idea of how those levels are organized. So that kind of leads us back into types. So we just had a name, a phone number, and a business card. These labeled structs. Those would be called types. We're going to refer to those as types. Just remember, types of structs, which are basically just data containers, which are basically just organized numbers. So when you hear the term type with a certain label, you can just think of it, that's organized numbers, right? That's just some sort of container, potentially of other containers, that all at some point just boil down back to really basic floats or integers. Remember, organized numbers, structured numbers, hence structs. So structures help us to keep numbers organized, know how to interpret which numbers, and sometimes letters, but in Blender, 99% of the time we're going to be interpreting numbers. And remember, at the base level, you're just dealing with types of numbers, either integers, which are just whole counting numbers, or floats. And then there's just lots and lots of containers of these, and depending on the labels of the container, Blender knows how to interpret them, and we can kind of dig around and see how everything's structured if we're interested in it. If any of this kind of went by you too quick, just hang on, watch the next couple of videos, and then you can come back to this one. Hopefully the next couple of videos will give you more context for why we're going over this.